Sorry, it's taking long. My PC is kind of lagging for some reason. Too many things going on, so
Been able to get a question?
yeah, I just got it.
Okay.
So I'm gonna paste it in here right now. Right. So this is the problem we'll be tackling today. It's Leetcode. Okay. Uh yeah, you can join the collaboration session and so you can interact with the code as we go. So we're going to be tackling valid parentheses, and the problem basically says you're given a string S, and this string contains either of these characters. Can either be an open curved bracket, a closed curved bracket, or an open or a closed curly brace, or an open or a closed square bracket. So there's nothing else. There's no numbers, there's no letters, just different types of brackets. So determine if the input string is a valid set of parentheses, right? So the first question would ask what do you mean by valid, right? So how do you know if a set of parentheses is valid or not? So these are the rules. So they have three rules. So open brackets must be closed by the same type of bracket. So that means if you have an open bracket in front of a closed bracket, it must be of the same type, like this. So if you have this, right, this wouldn't be valid because you have a curved bracket being closed by a curly brace. So that's not valid. So whenever you have something like this, it's not valid. So the next one says open brackets must be closed in the correct order. So that means even if I have this, right? If I have a curved bracket and let's say a square bracket, right? And then I close this guy before closing this guy. Can someone say if this is valid or not? I mean, uh we have two opening brackets and two closing brackets that are of the same type. But is this valid or not?
No.
Good. And the reason is because they are not closed in the same order. So even if you have like a pair, a complete pair for each set, right? But the order in which they appear is not right. So you have to close the inner bracket before closing the outer one. So this square bracket has to come before the curved bracket. So that's the right order. So that's another rule. And then the next rule says every closed bracket must have the corresponding open bracket of the same type, right? I think this is basically boils down from this guy. So it means the number of open brackets must be the same as the number of open brackets of a particular type must be the same as the number of closed brackets of that same type and vice versa. So yeah. So let's look at some of the examples they have. So the first example we have this. Clearly this is valid because it's just an open and a closed curved bracket. So you return true. So can someone tell us what our output type would be? If anybody can go. So your input is a string, right? So what would your output be for this problem? See, I see an answer in the chat. Yeah, a Boolean, that's right. So it's either a true or a false. So you want to assess the string to see if is this valid, yes or no, or true or false, basically. So it's a Boolean or Boolean. So example two, we have this one, right? They have an open, a closed, right? Open, closed, open. So again, this is valid because we have each of these closing brackets closing the corresponding opening brackets. So that's perfect. And we have them closing in the same order. We don't have like misplaced orders. And we have exactly the same number of opening brackets as we do for closing brackets. So it's valid. So for this input, this is interesting. They have this is a basic case. So you see that they are definitely not corresponding. So it's not valid. Example four, this is valid. Why? Because it's similar to the first example I gave here on line 7. But this in this case, I changed the order. So this is basically asking you the order is correct, right? So you close the inner bracket before closing the outer ones. So that's valid. I'm trying to think of I'm trying to think of can anyone think of edge cases that we could try to? So we're on the understand step right now. So can you think of edge cases? So maybe the first one, I'd say maybe an empty string, right? So what if you
Right.
have an yeah, an empty string? Any other ones? What if you have something like this, where yeah, so this is not necessarily a special edge case, but something I want to look at. Can anyone think of edge cases? So in this case, the major catch is each of the closing brackets, the order is correct. The opening brackets are being closed by the corresponding bracket. But the catch here is you have more closing brackets than you do for opening brackets. So you want to make sure you're accounting for that. Any other thoughts? Any other tricky cases we would want to consider before we move on to the match step?
It looks good.
Yeah, that looks good to me.
So what approaches come to mind when you digest this problem? What do you think? What you don't have to bring up the most optimal method, right? So you could talk about the first thought that comes to mind when you go through this problem. What do you think you need to do? Like what kind of how would you approach this problem, basically? And if you have the optimal solution or the optimal approach, that's fine too. You could share. Put it in the chat if you, or you can type it in there because you have access to the code. Any thoughts? Okay, let me give a hint. So one of the approaches you could use, we talked about it today in class, right?
All right. So,
Mhm.
sorry, me and myself, I caught that one. The way I would approach it is to basically check if every create a way which is going to be stacks to check if every open bracket that I open is every opening bracket is closed by the same type of bracket in the sense of um if if I look through the string and it's an open bracket, I'll add it to the list or to the stack. And then if I come across a closing bracket, I would check the last bracket that was added to the stack. And if it's the same type, basically, I would pop that out and I would continue that until if I get to the end of the string um and the length of the stack is 0, then yes, um the input was valid. They were all balanced. The parentheses were balanced. However, if it is not oh, however, if it's not balanced, if it's not empty, then they were not balanced, and that will return false.
Okay. Yeah. Actually, you went ahead, like a step ahead into the flying step, but that's fine. So I heard you mention stack for the tools
Yes.
you'd use. Any other maybe data structures or aside to stack? So I know you said the stack would like hold the bracket, I think. But aside that, is there any other thing you think you would use, or not just him, any other person? So so because of time, we'd move on. Feel free to also put it in the chat. Any thoughts you have? I'm trying to look at the chats to make sure I'm keeping up with it. So good. So a stack definitely applies to the problem. So that's cool. I think we'd also need a dictionary or some form of hash map. Python, yeah, basically call it a dictionary. So we could use something else aside the dictionary, but I chose to use a dictionary because then we're able to pair, right? We have key to value pairs. So we're able to pair those brackets together, like corresponding brackets. So I could have the opening curly brace paired with the closing curly brace, and the same applies for the rest. So then I'm able to do the comparison really easily, right? Um, so that's cool. And of course, we'll have to look through the string. So what's next? The planning stage. I know Olayiwola sort of went ahead to talk about how he would actually use a stack to solve the problem. Um, so from what I heard, the stack would keep track of the opening. So as you look through the string, right? Correct? So stack to track to store opening brackets, right?
Yeah.
Okay. So can someone guess what the dictionary would do? I think I entered that already. So what would the keys of the dictionary be? And what would the values of the dictionary be?
I want to suggest, can you turn off the autopilot? Is there kind of giving the
Oh, okay. Let me try to do that. This might take a while. Typically like an AI thing somewhere.
So yeah, it's at the bottom
Bottom
right.
right,
Yes, there, I believe.
Copilot. I see it.
What the brackets go inside the dictionary?
Yeah, so we have two kinds of brackets, right? So which one should be the keys of the dictionary and which one should be the values for the dictionary? Because you have the opening bracket and the closing bracket. So one of them has to be the keys and one of them have to be the values.
Just disable completions for Python or completions. Just disable completion.
That's right. So, all right. So back to this. Terminal down. So yeah, I see something in the chat. Okay, you are suggesting the values would be. So yeah, so we have three kinds of brackets, right? So it's either going to be a curved bracket, a square bracket, or a what's the other one? A curly bracket. But the goal is you want this dictionary to be able to pair them up, right? So with the key, you'd be able to get its partner. So the key would be maybe the closing bracket or the opening bracket. And in this case, I would go with the closing bracket and I'll tell you why in a second. So basically a dictionary would look like this. Uh, so you have the closing bracket for this guy. Let me just write this way. And then its partner would be its corresponding opening bracket. And the same will go for this guy. Its partner would be its corresponding opening bracket, right? Uh, and you have this guy, its partner would be its corresponding opening bracket. So this is the dictionary, what it looks like, right? So the reason is when you're doing your loop, right, and you want to compare if the values are the same or not, you would want to say, I've encountered a closed bracket. So is the opening bracket uh this guy, for example? How would you do that? You would basically index or use the key to find the partner. So we would see that in a second, maybe when you're implementing the code. But the goal is to be able to get the partner of the, to be able to retrieve the partner of each closing bracket. The reason you're not using the opening bracket is because the opening bracket is already being stored in the stack, right? So the fact that we already have the opening bracket in the stack means that we have to, yeah, we have to be able to match the opening brackets when we get the closing brackets. So that's why the values are the ones that are the opening brackets, so that we're able to retrieve them whenever we encounter a closed bracket. I know that's a lot of like jumbles, but when you actually get to write the code, it will be clearer. So what do we want to do? So we look through the string, right? I know we're running short on time, so look through the string. And so for each character, right? So what happens if the character is an opening bracket? So if opening bracket, what do we do? Any guesses? So if it's an opening bracket, it means if it's this guy, or this guy, let me write this down. This guy, or this guy. So want to remember our stack keeps like stores all the opening brackets. So what do we want to do? our stack is initially empty, right? So we're looping through this string and we encounter an opening bracket. And remember, the purpose of our stack was to keep track of opening brackets that we've encountered in a certain order. The reason we're using a stack is because remember how we said that the inner brackets have to be closed first before going outside, right? So if you go back to line 45, if you are looping through, if you're looping through and then you encounter this is an opening bracket, this is an opening bracket, this is an opening bracket, the first time you encounter a closed bracket, you have to compare it with the one you just saw, not the first one, but the most recent one, right? So, and the best data structure that does that is the stack. Because if you imagine a pile of plates, right? If you put plates on top of each other, and the first time you go to retrieve a plate, the one you would encounter would be the most recent one. So stacks helps us get the most recently added element. So that's why we're using a stack instead of maybe a queue or something. So the stack data structure is what is our best bet here because it helps us get the most recently added opening bracket. So whenever we meet a closing bracket, we're able to compare. And yeah. So when we encounter with that explanation, what do we do if we encounter an opening bracket? You can put it in the chat if you don't want to say it out. All right, let me help. So if you encounter an opening bracket, remember the purpose of the stack is to keep track of opening brackets. So we want to append the stack. Sorry, we want to append the opening bracket to the end of the stack. So we append to stack, right? So what happens if it's not? So this is the tricky part. So what happens if it's a closing bracket? And what are the closing brackets? It could be this guy, or this guy. So what do you do if it is a closing bracket? So remember, like if you go back to our example, whenever you encounter a closing bracket, you want to compare with the most recently added, and you want to compare with the most recently added opening bracket, right? To see if they match each other. So if they match each other, you can continue looping through. But if they don't match each other, say this was a curly brace online, I'm on line 45. Say this was, let me try to increase this. Yeah, so I don't know if this helps in any way. So initially we had this, right? Oh, what? Yeah, so initially we had this, right? So so we come to this guy and we say, oh, this is a closing bracket. So let's compare it with what we just saw. And we compare it with this guy and we saw that they match. So we continue looping through. But if this was something else, say it was a curly brace instead. So when you get to this first closing bracket, you compare with the most recently added curly brace and they do not match. So then you know that because there is like a difference in there, the entire string becomes like invalid, right? So that's when you return false. Like the first time you encounter a mismatch, you know that the entire string is not valid, then you return false. If not, you continue. So how do you do that? So if closing brackets, you want to compare with the most recent, right? Compare with recent opening bracket. And So you return false if mismatch. Return false if mismatch. And this on this comparison step, that's actually where the dictionary comes to play as well, because when you're comparing, you come back to line 45. When you're comparing this closing bracket with the most recent opening bracket, how do you know what the partner of the closing bracket should be, right? Then you refer to your dictionary and say, hey, if the most recent opening bracket corresponds to the dictionary value of this guy, then continue. If not, then return false. So that's where the dictionary comes in. So that's good. I think this is a good plan. So we can actually go ahead and implement this. So the trick one would be, what if you don't have any opening bracket yet and you encounter you encounter a closed bracket. If you've exhausted all the opening brackets, if you've paired all the opening brackets, and you encounter a closing bracket, you know that the number of closing brackets are more than the opening brackets, then you return false. So those are some of the other things to look out for. All right. So we're good. We have 10 minutes. You can implement. Actually, please. So let's implement in the next 5 minutes and see if we can review. Let me see if I can get the starter code. See. So we have the string. So the first thing we want to do based on our plan. So our plan says define the stack. So the stack, because we're using Python, I don't think I know of any inbuilt stack, but you could use a list because it works really well. All you need to do is to check the last element whenever you want to, or you pop from the last element and you're good. So we're going to use a list for Python for our stack and then define a dictionary. So our dictionary is already like pretty well defined. So we just have to, so we have all the closing elements, right? So the first one is this guy and its partner is this guy. And what's the next one? This guy and its partner is this guy. And what's the next one? We have this guy and its partner is this guy. So these are the 3 pairs of brackets we want to use. So the next step on line 56 is to look through our string, right? So for character or for parenthesis in S, right? So for parenthesis in S, what do I want to do? I want to check if it's an opening brace. So if parenthesis, how do you do that? Can somebody guess how we could do that? How to check if it's an opening brace? Like really quickly. So we get a character and want to check if it's an opening brace. Hint, we already know how all the opening braces should look like, right? We know that they can either be 1, 2, or 3. So with that knowledge, how would we check? Any thoughts? Okay, let me help. So basically we can do this in multiple ways. And usually what I do is I could just say if parenthesis is in this, right? If it's in, maybe I'll just put a string of 3 of those things we want to check for, which is 1, probably not the most efficient way to do this, but
Let's check if
yeah.
if it's in dictionary. if parentheses in dictionary, and that would
Dictionary,
check if it's any of the opening
that would be,
parentheses.
that wouldn't that check for the keys instead? And the keys are the closing ones. So, but want to check for the opening one. Except we do dictionary dot values maybe.
Okay. They do whatever approach you think you want to go with.
Yeah, I think this is one of the most simplest way to do this. Even yeah, because you just have yeah. So if parenthesis is in this, it means if it's an opening. What do we want to do according to our plan? We want to append to the stack. So we want to say stack dot append parenthesis, right? So what this does is it pushes. So the list basically has numbers. Sorry, basically has elements in a row. So you just want to push it to the back of the like behind, not from front, but from behind. So basically just adds at the end of the list. So that's all actually. That's all we want to do for this guy. So the interesting part is when it's a closing parenthesis. When it's a closing parenthesis, our strategy says compare with the most recent open bracket, right? So I want to compare, yeah. So I want to compare with the most recent open bracket to see if they are a match, right? So how do we do that? So the most recent open bracket, right, is basically the last element in the stack. How do you get the last element in the stack? You could just index. And one way to do this is to use the index -1. So the index -1 gets the last element in a stack. Sorry, in a list or in a stack generally. So if stack -1 is the same as now our dictionary comes to play. We want to say if the opening brackets that we just saw is the same as the opening bracket that's the partner of this guy. So how do we know that the dictionary comes in? So dictionary of our parentheses, like if they're the same, we want to do, what do you want to do? We want to continue, right? So it's really nothing much. But here's a trick one. So what happens if, so go back to line 45, right? So when we compare, say this was this. So when you compare these two guys, they are the same. You want to continue, right? So the first time you encounter a closed bracket, you want to compare it with this guy over here. But then there's these guys in the middle. So what do you do about this? We are basically done with this, so we can pop it out because you're done with it. We would never need it. You're going all the way to the right. So you are basically done. So you want to pop this guy out so it doesn't obstruct. So that's what we're going to do. So if we find this to be not true, so we're going to pop. I could have popped this from the if statement too, but yeah, this is also another way to do it. So if they are the same, you want to pop from this guy. Else, what happens? So if they are not the same,
You want to return false.
yeah, you return false. Yeah, so if they're not the same, you return false. So this makes sense, right? So at the end, you'd be tempted to just say return true, right? Because that means you're done. But here's the trick one. If you have more opening brackets than you do for closing brackets, right? All of these things is going to work if they are in the same order and if they match each other. But then you would have some opening brackets in the stack, right? So, but you don't want that. So you basically want to check if there's anything left, right? So if there's anything left, if stack, you want to return false, else you want to return true. So this is also a trick part. So talking about space and time complexity, we're out of time. Let me try to be fast. So the time complexity, does anyone want to guess what the time complexity would be? So since we're just, if you look at this critically, we're just looping through the string once. So that's really the only looping we're doing. So the time complexity would be of n, where n is the length of the string, and the space complexity. What am I doing? So CC and SC, space complexity, time complexity. In this case, what extra spaces are we using? So we had the dictionary, but it had a very fixed space, which is 3 elements. And the stack, yeah. So the stack can really grow depending on how many opening parentheses we have. If we have all our elements as opening parentheses, then would end up pushing everything to the stack, and the stack would have a length of n. So that's the worst case. The time from space complexity is also of n, where n is the length of the string. So yeah, if you have any questions, you can put them in the chat, or I don't know if we still have room, Tabu, for questions.
I may need to wrap up only because of the survey. So we want to give them a chance to like fill that in now. So I could take over now while you like prepare that if you have it, but if not, it's okay. But I think this is a good stopping point only because of time. But thank you so much, Sunday, for that.
Yeah,